Hi, my name is Marcin, and today I want to show you how to create water drops in Flutter. And what I mean by water drops, I mean something like this. Basically, today we will create a widget that we can put on top of another widget that looks just like a water drop. Um, if you don't care about how to do it and just want to use it, there is a package I created on pub water drop, and you can simply just get it and use it. It's very simple. However, if you want to learn how it's done, then stay with me. So we will start with a very simple application. There is a material app where is a scaffold. We have an up bar and a column with one card. And this card is just a card with a color or some padding, column, text, button. Very simple. And now we will try to create some water drops. So we will start with creating our water drop widget. Let's call it, wait a second. Let's call it, well, water drop. All right. And for each water drop, we will need 4 main parameters. It is top, meaning distance from the top, distance from the left, width, and height. And also we will need a child to to have like a child, a widget. Okay, so let's declare all those. So we will have top, we will have left, width, height, and a child. All right. All of them should be required. Well, actually, never mind. All of them should be required. So, what we will do is we will have a stack. First, let's just have a stack with only one child, which will be the child. And here we can wrap our card with water drop, and the child is card. So this should change absolutely nothing, and it did change absolutely nothing. Okay, so here we can pass some parameters. Let's say top will be 100 pixels, left will be 150, width 200, height 200. It still does nothing, but what will start? We start with a clipper. So how do we actually want to create those drops? What we want to do is cut out the circle in the card, do some operations on this circle to create this effect of a water drop. And then we'll just put this circle on top of the of this card, of this child. Yes, so here we have the child, and on top of it we'll put this transformed circle, which will look like a water drop. And to do this, we need to cut out the circle from the actual widget. And how do we do it? We do it by using clip path widget. And clip path widget takes 2 main parameters, which is a clipper and a child. Okay, and the clipper is custom clipper object. If you go here, we can see it's custom clipper, and this is something we need to implement. So it will be oval clipper extends custom clipper path, and it should override two methods, getClip and shouldReclip. ShouldReclip, as a very performant developers, will just say return true. And getClip is it should return a path which will define what we actually want to clip, what we want to cut out. So here, what we will do is we will return a path, and we will add to this path an oval, and oval is can be done by rect from center. Yeah, from center is good. And this requires offset, width, and height, which we can provide. So it will be final offset center, which will be the center of the drop. Final double width, final double height, and let's add it to constructor. Let's make it named. All right. So here we can do oval clipper. Now we don't have center yet, but we can for sure provide width, and height. All right. Now, how do we calculate the center? So we do provide the offset from like the distance from the left and from the top. From the left and from the top, like the from the widget we are using. So if we are using this card, the left parameter will be distance from this, and the top parameter will be distance from this. So if we have left and top, and we have width and height, then we can actually get the center really easy, as it will be just left plus width divided by 2, and top plus height also divided by 2. And now we can pass it here. And if we reload, oh, we have an error. This was called on null. We are having center. Did we pass the parameters? We did. And here we didn't use it. Center, width, height. Wow, nothing changed. Well, nothing changed because we cut out the part of the widget and we just used it on top of this widget, so we cannot see it. However, if we just comment the child from the stack for a while, we can see this is what we cut out. So we can change the parameters a bit. Maybe let's make it a bit smaller. All right, and let's move it to the left. Okay, let's make it like this. So this is our circle we just cut out. Let's uncomment it. Now, what we need to do is to add a gradient on top of the circle, which will go from the black, like it will put a little like lighting effect on our bubble, and what we want to do is to like have a linear gradient from like black to white. It will just look like, it will provide this feeling of some like light distortion, let's say. So what we can do is we can create it here. Let's say it will be child with gradient, and this will be a container. Child will be the child, and here we can add foreground decoration, and foreground decoration will be a box decoration with a gradient. Now we can use linear gradient here, and linear gradient what we can provide here is begin. And for now, we can say that the begin is alignment top left. The end will be alignment bottom right. And we can specify the colors, which are colors black and colors white. So if we do it like this and add it here, then we will see this, which is not really cool. Technically, we could add some transparency to the colors and it would look better, but it's still not what we need. And what we need is actually to specify background blend mode with blend mode dot overlay. Now this will cause, okay, I'll just show you. Okay, it changes nothing. What if I do hot restart? Okay. You can see it like kind of like blends with the child instead of just being on top of it. So we have this very small gradient, and now the question is, why is it so small if we provided black and white? And it is because the alignment top left is actually pointing to, well, the thing is that we are actually using the whole child. So the alignment top left points to this point and bottom right to this point. So if we moved it to the left, then you can see it is much darker than in the middle. And it is not good. We want each of our drops to look like very similar. So what we need to do is to calculate what alignment should we have in here. And to do this, at first, we will need to know the size of the child we are using. And this is problematic because in Flutter, in the build method, you actually cannot get the size of the child because, well, the child is not built yet, so you don't have it. However, you can do a trick which is not recommended, but it works. So what we can have is, let's make it smaller. We can change water drop to be stateful widget. And let's have size, total size here. Now, here, if total size is null, so basically it means in the first build, we can do something like schedule binding that instance that add post frame callback. What it means is after the build method has already like run. Oh, actually, no, this is add post frame callback. Yeah. So after the build method is already done, do something more. And what we want to do is after the build method is done, we wanna do set state total size is context.size. Okay, so because we cannot access the size at the start, we need to do it after the build. And then we will call set state, so it will rebuild again, but this time it will not go again to this method because total size won't be null anymore. So if we, for example, print total size here, it should be at first null, and then, yeah, we have some size. All right. So now this size can be null. So let's have a size object, which will be by default total size. But if it's the first build, let's have a placeholder which will be media query size, so the size of the whole screen. All right. Okay. So now we need to calculate the alignment. First, let's calculate the alignment of the center of the dot, which is here, because this will be easier. And to calculate the alignment, what it actually is. Okay, so how to actually calculate it? Alignment goes from -1 to 1, where -1 is like the extreme left and 1 is extreme right when it comes to the x-axis. And when it comes to y-axis, it's -1 is top and 1 is bottom and 0 is middle. So first of all, we need to think like how to actually get those, how to get the our parameters, the top, left, width, height, and the size, and map it to the alignment, meaning how those parameters, like what is their position like relative to the whole widget. And what actually is happening here is that we can say that, okay, we can just try to write something. For example, if we do left, or now widget.left minus size that width divided by 2. Okay, and let's do the same for the vertical axis. So it will be top minus size that height divided by 2. Okay, so now you can see that if the left is equal to width divided by 2, so it means it's in the middle. Okay, so what I was thinking is that if left is in the exact middle, then the left minus size that width divided by 2 will be equal to 0, which is good because if something is in the middle, then the alignment should be 0. And now it's also good if this will be, however, if this, for example, will be 0, then it will be minus half of the width. So, and it should be -1. So what we can do is actually divide it by size that width by 2. And technically it is right. Now notice that if the left is 0, then the whole thing will be -1. If the left is equal to the size width, so it's extreme to the right, then the whole thing will be 1. So it's also good. And we can do the same for the top. However, we are using left and top here, and left and top are like the distance from the, it's this distance and this distance, and we want the distances from the center because we want to calculate the alignment of the center. So to do this, we cannot use widget.left, we need to use center.left or center.dx and center.dy. So this will calculate the alignment of the center. Now to so if we have it like this, actually I have no idea what will happen. Okay, it will look like this, whatever. So here, now we need to calculate, we shouldn't use this alignment, we should use the alignment which will represent this point. All right, and now to do this, we need to know what is the alignment, like what is the difference between this point and this point in like relative look. Okay, it's so hard to explain it. Maybe I will just like show you the code because it's really hard to explain it, and once you see the code it's very simple. So if we call it like alignment modifier, it can be just the width of the widget divided by the width of the whole child, and do the same for the height. All right, and once we have it, here we can subtract this alignment modifier. Here we can add alignment modifier, and it will look like this. The begin will be here, the end will be here, and yeah, so now wherever we put our drop, it should look the same, right? Yeah. Okay, so this was like the hardest part. Now it's all much simpler. So we have this gradient. We also need to add two more like light objects. One will be the drop shadow underneath the drop, and the second one will be light on top of the drop. So let's start with a drop shadow. We will create a stateless widget. Let's call it drop shadow. It will have final double. Okay, I will just copy it from this. All right, it doesn't need the child, and it will be a positioned left, top, height, width. All right, so we have something that has the same dimensions as our cutout and is in the same position. And the child will be just box decoration, and it can have shape, not shape, radius, I believe. And I'm very bad with radiuses. I always do it wrong, do it like the bad way, and I never remember how to do it correctly. So I'll just look it up. Okay, so it's border radius, that's all. And here we provide radius that elliptical, yes. And elliptical gets the radius, like the horizontal and the vertical radius. So it will be width divided by 2 and height divided by 2. All right, it's all red because it cannot be box decoration, obviously. It has to be decorated box with decoration, box decoration, yeah. All right, and we can also add shadow, and the shadow will be a simple box shadow with some radius, some offset, so it will be moved to the right. Let's say 4, and the color will be black with some opacity. All right, now let's add it. Let's add it here. No, we need to add it here with height, left, and top. All right, and if we do hot reload, we can see small shadow in here. Okay, now let's add a white dot here, so it will like do this like glow effect. And to do it, it's very similar to what we have here. So we'll just change it, drop shadow to light dot. Now it will be left top, so here. And since the dot will be smaller, we can move it a bit to the right. So let's say we will add a bit of width and a bit of height to the position. And let's make it smaller. Okay, so if we just put this light dot inside our stack, okay, we have it in here. We can move it a bit to the left and to the top, and maybe a bit smaller. Yep, and obviously it cannot be black. So let's make it white. Actually, okay, maybe we don't need to move it, and let's make it more visible. All right. Yeah, maybe. Yeah, okay. I think that's good enough. Let me just think a little if that's good. Yeah, I like it. All right. So now, actually the last part of this is to create a distortion effect, which is like, you can see that here the widget is a bit scaled up, and you can see like some weird behavior on the sides, right? Actually, maybe here. By the way, follow me on Twitter. Here you can see it's like more clearly. Yes, that there's like this effect, and when the animation is run, yeah, you can see this effect like changes how we see the what's underneath. So how do we do it? What we can do is we can create a series of layers of this cutouts of those like circles. However, each layer can be a bit smaller than the previous one, but then it can be also scaled a bit. So we have like a big circle, then we have a smaller circle, but we scale it a bit to be bigger, and then another small circle, make it bigger, smaller circle, make it bigger. And this will provide a zoom effect, as well as you will see the like it will look really smooth. Yeah, so let's just do it. So here we have this clip path, and what we want to do is provide, let's say, 8 of those clip paths. Here we have an index. Yeah, okay. And here for each of those, now if we hot reload, nothing changes because they're all the same. However, if we do something like this, that each of those circles is a bit smaller, we can make it times 1 minus like a very small factor times I. Hot restart. Nothing changes. Okay, nothing changes because we cut out smaller parts, but they're still like exactly the same. So what we also need to do is we need to wrap it in transform that scale and provide a scale. And scale will be also by default it will be 1, but just like increased a bit. Bingo. Now, okay, on this you cannot see it. However, sometimes I had like weird artifacts in here. So what I added here is clip behavior hard edge. Okay, here you don't see any difference, but sometimes there was a difference, so it's good to have it here. Actually, let me just... No, okay, whatever. And yeah, wow, that's actually it. So you can see that it is much bigger in the center. You can see that some of those layers in here, and oh, actually, it's not everything, because if we had our child like here, it would break, because the scale is by default aligned to the center. So we need to here specify the alignment. We calculated before. This is the alignment of the center of the drop, not the center of the widget itself, because the center of the widget is here. That's why this looks very weird. But now anywhere we put it, it looks very similar. Yep. All right. So we have our drop. What we can also do, we can animate it. How we can animate it? Actually, it's very simple, because you can see that it's a normal widget, right? So, okay, before we animate it, I want to show you something that is very, I think it's rather important, because here we are having a stack with 8 of those cutouts, and each of them creates a child with the gradient, right? So if we look in the Flutter performance and we see widget builds and do like hot restart, you can see that the raise button was built 9 times, and the text and the card and the text and so on. This widget was called 9 times, and it's better when you don't rebuild your widgets like 10 times instead of 1. So before we go to the animation, it's just worth mentioning that it may cause some performance issues. And if you have an idea how to do it without all those rebuilds, let me know in the comment. I didn't figure it out. And yeah. So just remember that it may be slower with the with these water drops. So to make it animating, let's make our card stateful. Let's add single ticket provider state mixin. Then we have animation controller. In the init state method, we initialize our animation controller with val sync this. It's this because of single ticket provider state mixin. And with the duration, let's make it 2 seconds. Now what we can also do is call method forward, not forward, repeat, with the reverse flag to true. So it will automatically start and repeat itself. Then we also add this pause method. And in the build method, all we do is wrap it in animated builder with the builder method, which has context and child. So we have our child, which is a bit too big. So we copy this, we remove the water drop, So the card itself, it doesn't change at all. It will not be animated, so we can provide it as a child to optimize a bit. But here we will do return water drop with all those parameters and child. All right. And here we can say, oh, we need to specify the controller, the animation. And here we can say that, for example, top will be 30 plus animation controller that value times 30. So it will move horizontally, vertically. And let's hot restart. And it looks like this. Now you can see the number of builds of container. it's enormous. Yeah, okay, it doesn't like look really smoothly, but it does in the release mode for sure. Now, actually, this should like let you know that you may have performance issues if you do if you use this package. Obviously, in debug mode, like it's not. It doesn't need to be this way. Here, this is the GIF I posted on my Twitter account. Here it looks much more smooth. Yeah, but like again, please use it carefully. All right. So actually, that's maybe if I do hot restart or remove this. Whatever, you can see it's animating. All right. So I believe that's it. We had our card. We added a gradient, provided a drop shadow, provided a light dot, and then copied this card 8 times, each a bit different parameters. And I will stop this animation because it makes me sad that it's so slow. Don't run, please. Yep. All right. And that's what we got. Water drop in Flutter. Now, if you wanna see the code, I'll put it in the description. Also, you can find it directly on my GitHub, or you can just go through the package on pub. Let me know if you like it. Let me know if there are other things that probably will never see any production app but are cool to create in Flutter. And that's it. Thanks if you stayed the whole time, and see you again. Bye.